Mosquitoes are arguably the deadliest hunters on the planet. When one lands and pierces your skin, it can easily pass along severe, sometimes fatal blood-borne diseases like malaria, dengue, and chikungunya. But then there is HIV. Since the start of the epidemic, this virus has carried decades of fear, stigma, and intense public anxiety, often driven by ignorance about how it actually spreads. Growing up, most of us were taught a very clear, strict rule. HIV spreads through the mixing of infected blood, and the most visible high-risk example of that is the sharing of dirty, used medical syringes. If you look closely at a mosquito, its snout looks exactly like a tiny biological syringe, so your brain naturally connects the dots. This leads to a terrifying yet completely logical question. If that insect drinks the blood of an HIV-positive person and then lands on you right after, shouldn't that infected blood mix directly into your bloodstream? By human logic, the flying needle theory seems flawless. But if we look closely at the actual biology of this insect, we find that a mosquito is a complete dead end for the virus. The first reason lies in what happens the moment a mosquito takes a meal. When it drinks HIV-infected blood, that fluid travels straight down its mouthparts and directly into its stomach cavity. Here, we have to look at how HIV functions. To survive and multiply, the virus needs a highly specific host environment. It spends its time seeking out human T cells, the specialized immune cells it hijacks to replicate. But an insect's biology is entirely alien to ours. A mosquito possesses absolutely zero human T cells, leaving the virus with no compatible environment to dock or begin its replication cycle. HIV is not some indestructible force. Under a microscope, you can see it is a fragile structure that degrades quickly without the right support system. Without those required T cells to hijack, the virus is left exposed in the mosquito's gut. The insect's natural stomach acids and powerful enzymes simply break the virus down, digesting it entirely like any other standard protein. The mosquito is essentially eating the virus, not incubating it. This digestive process acts as a massive biological firewall, chemically destroying the threat before it can go anywhere else. But what if digestion doesn't have time to happen? Say the mosquito gets swatted away from an HIV-positive person and bites a healthy person within seconds. This brings us back to the flying needle myth. We assume the mosquito is operating a single hollow tube, sucking blood up and pushing it back out. If you dissect a mosquito's proboscis, you'll find it is actually a highly complex array of 6 distinct tools. Most importantly, it contains 2 completely separate internal channels. These channels are strictly one-way streets. One tube is exclusively designed to act as a vacuum, pulling blood upward. The second tube operates in reverse, pushing the insect's saliva downward into the bite. That saliva tube is crucial for the mosquito's meal, as it pumps in special anticoagulants that prevent the victim's blood from clotting while it drinks. So, when a mosquito bites you, it is only injecting its saliva. Any blood from a previous victim is trapped in the upward suction channel or already in the stomach. It is mechanically impossible for the insect to pump old blood back into a new host. Still, you might wonder about the outside of the mouthparts. Could a microscopic droplet of infected blood just resting on the surface of the snout get pushed into your skin and cause an infection? To answer that, we can look at this visual scale comparison to understand viral load. For a human to actually contract HIV, the body requires exposure to a massive concentrated quantity of the virus to overwhelm the immune system. The absolute maximum volume of fluid that could physically stick to the outside of a mosquito's needle is incredibly small. Even if that tiny droplet was fully infected, it is mathematically thousands of times too small to initiate an infection. Researchers have spent decades confirming these mechanical limits through high-powered microscopic observation and rigorous laboratory testing. Even in a worst-case scenario where the virus somehow bypassed the stomach acids and the two-way plumbing, the sheer mathematical scale of the viral load requirement acts as an impenetrable third firewall. The biology of the mosquito sets up a perfect gauntlet against this specific virus. The threat is digested chemically, blocked mechanically, and defeated mathematically. This doesn't mean mosquitoes are harmless. They still pose severe global health risks and require serious community control. But you should reserve that caution strictly for true insect-borne pathogens like malaria and dengue fever. When it comes to the specific anxiety of catching HIV from a bug bite, you can permanently erase that fear from your mind. The broader societal stigma surrounding HIV and AIDS is kept alive by exactly these types of logical-sounding but scientifically false rumors. You can actively combat this stigma by sharing these strict biological facts with your friends and family. It takes verified science to replace historical fear with actual truth.